let's see if we can solve this one. This one shouldn't be too hard because on the page it was like 2 stars in difficulty. But I do know the person who said this, and it's supposed to be a pretty good puzzle, I think. What's the rating on this one? Right, 97%. Yeah, it's pretty good, 97%. Okay, the rules of the puzzle are normal Sudoku rules apply. So 1 to 9, place digits 1 to 9 in every row, every column, and every 3x3 box. Digits on the really long blue line, so all of these digits, which I'm not going to draw in, but they must have an equal sum within each box it passes through. You can see what I'm doing, right? I believe you can. Anyway. Each time it passes through a box counts as a separate sum. So whatever this sums to, let's say these cells, have to sum to these cells, the same sum. Which also has a sum to this, which is the same sum. So basically every color sums to the same value, and every time it goes into a new box, you get a new set of digits which sum to the same total. Okay. Also, cells separated by a white dot, these and these, must contain consecutive digits. So if say this was a 1, then this must be consecutive to it, so it must be a 2. And if like this was a 3 or a 4, then this would have to be either a 3 or a 5. Next, cells separated by a black dot have a 1 to 2 ratio. So this is one digit is always twice of the other digit, and it can be it can be in any direction you want. So this can be double this can be double this. As long as one is double the other, that would work. Okay, so that's the puzzle. I guess we'll try to solve it now. I saw decided to do was too easy. Yeah. It's crazy though that you can make Sudokus without any digits in them at all. I think the most interesting thing right now is this cell, these set of digits, which I'll color in orange. It happens to be the same as this set of digits. And in fact, a lot of digits come in sets of 3. Or no, there are only 2 others. No, yeah, these also. All of these. Wow, okay. All of these are 3 cells long. I think I'm coloring all of them in just cause. I'll color this in grey. Oh no, your Wi-Fi. I'm sorry about your Wi-Fi. But this does give us some decent prediction, or some decent restriction, because minimally these cells must have 1, 2, 3, 4, 5, and 6 there. So minimally these cells must sum to a 21. I cannot type 21 in here, but minimally these must sum to 21. And so these are actually pushed very high up. But at maximum these can sum to a 7, 8, and 9, which sum to 24. So that means the sum of each line here is about 24. Or not about, it is 24. What else do I see? Oh, well, it goes around the entire grid, right? That's also pretty interesting because how many sets does this take up? This takes up 8 sets, 1 for each box. So we have 8 sets of the same sum around the ring. Is this Minecraft game map? What do you mean, the music? Yes, it's Minecraft. It is Minecraft. Well, it's Minecraft music. Okay, well, another thing I realized is that this box over here, in a box, you must have the digits 1 to 9, and so digits must sum to 45, because that's what happens if you get all the digits 1 to 9 summed up. And we have 2 of the same sum in here, which must always sum to an odd number, so like x and x sum to 2x, so this is odd. And then even, and then an odd number, which is the total sum here, minus an even number, gives you an odd number. So this is an odd cell, which is 1, 3, 5, 7, and 9. These are even cells, which are 1, 3, 5, 7, and 9. I think we can restrict this even more, because a 9 here would make this a 45 minus 9, that's 36. Divide that by 2 and you get 18, but we know this has to be at least 21. So in fact, it can't be a 9. It can't be as big as a 9. Then we do the same with 7. 45 minus 7 is 38. Divide that by 2, you get 19. And we have to be at least 21, so it doesn't work. And then 5 also doesn't work, because 45 minus 5 is 40. Divide by 2 gives you 20, and this needs to be at least 21. So again, 5 doesn't work. So 5, 7, 9 here are all removed from this box by equivalent logic. What else do we have? Well, I mean, if this was a 3, then this adds up to 21. If this was a 1, this adds up to 22. So this is sort of useful. Because this has to be at most 22, right? Yeah, at most 22. Which means it's either a 1, 2, 3, 4, 5, 6 or a 1, 2, 3, 4, 5, 7, I think. That's the only way you get 22. So it must have a 1, 2, 3, 4, 5 in it somewhere. Oh my goodness, what am I doing? Can I do this? 1, 2, 3, 4, 5. This is so annoying. But that means 8 and 9 must exist outside. Oh, over 9 is 8 exists outside as well. Oh, these cells are, these cells are all restricted. They can't be 5. I mean, that's not a very big restriction. Oh, thanks. Actually, I feel like this logic a lot of other people will get as well. But hey. Anyway, yeah, these can't be 5 because this cell can't be like double of 5. Can't be a lot of other stuff either. So yeah, it can't be half of 5. It can't be double of 5 because those don't fit in the grid at all. So these can't have 5 in them. Oh, I want to say that these have to be pretty large as well, although I'm not entirely sure that's true. You could have a 1 and a 2. So these don't have to be that large. It could even be a 2 and a 1, I think. That's possible. Yeah, it doesn't help, does it? Although I know this is a 21 or 22. Could we do some math then? Because, yeah, we could do some math with a huge ring around it. Because these contains 8 sets of some value. So I'm just gonna take out my calculator here and see what 8 sets of 21 is. That's 168. Wow, okay. 106. This either adds to 168, or if we had 8 sets of 22, that would be 176. What does that mean for the grids outside? Well, because this ring contains firstly 2 sets of 1 to 9 here, it also contains 2 sets of 1 to 9. But if we said that, then we'd be counting these twice. So we'd be counting these cells 2 times if we said there are 2 sets of 1 to 9 and then another 2 sets of 1 to 9. Which means this ring consists of 4 sets of 1 to 9, which would be 4 times 45, that's 180, minus these 4 cells. Ah, that works. I mean, that helps, because if these were 22, if the sum was 22, then these cells would have to add to 4, because 22 times 8 is 176, and these in total are 180 minus these 4 cells. So 180 minus these 4 cells gives us 176, so these 4 cells must be a 4 in total. And the only way to do that is if you had 1 in each of these boxes, which definitely fails because then you'd have, 1s repeating everywhere. So this can't actually be 22, can it? Meaning, this is 21. This is in fact 21. 21 here would give us a 3 in each of these cells, I think. Because 21 here gives 42 here. 45 minus 42 is 3. Yes. Oh my goodness. Wow. Huge brain. Okay. So that was a lot of logic to go through, but I think that was decently simple to spot. I don't know, man. Which means that these have to sum to 21 and have to be 2, 3, 4, 5, and 6. These have to then be 7, 8, 9. If we go back to these 4 cells now, we remember that if it was 21, then it would be 8 times 21, which is 168. And 118 minus that gives us 12. So these 4 cells sum to 12. Okay, that's not very helpful because they could be anything. I will mark them down just so I can remember that those cells are somewhat important. I do not. This has to be quite big, and so does this. This has to be at least 6. At least 6. These have to be decently large as well. Oh, we realize that these can't be 5s. Yeah, these can't be 5s. What then? I don't really see much to do with these. Oh, I realize. Yeah, these are even easier to spot now because we know that this sums to 21, right? This sums to 21. So these sum to 42, and therefore this sums to 3. The only way to do that is if you had a 1-2 pair. And same here, these sum to 42, so this has to this has to be a 1-2 pair. So in fact, now these can be 1 either, because a 1 here would force a 2 there, and similarly a 1 here forces a 2 there, because this must be double of 1, it can't be half. So none of these can be 1 either. A 2 in here would force a 4 up there, a 3 would force a 6, a 4 would force, it could be a 2, and then it could be an 8 as well, and then a 6 would force a lot of other stuff. Oh, well, yes, okay. We know that all of these, what cannot be near a black dot? And the answer is 5, 7, and 9, because 5 cannot be near a black dot. You can't have something half of 5 or double of 5. 7 can be near a black dot, because then you'd have something that's double of 7, which is 14, or half of 7, which is 3.5. And 9 cannot be beside a black dot, because you can't have something that's double of 9, that's 18, or half of it, which is 4.5. So you can't have 5, 7, 9 on it. We know that these are near a black dot, so they can't be 5, 7, 9. And then these are clearly not 5, 7, 9 either, because they're 1 or 2. So these 3 cells are 5, 7, 9. And then this is therefore not an 8, because, you know, can't be 5, 7, 9. So 8 exists on one of these cells. It cannot exist on any of these cells and any of these cells. So 8 must be in one of these cells. And 8 must always touch 4. If you have 8 on a black dot, the other side has to be a 4, because it can't be double of 8. So wherever 8 is, there is a 4 beside it. So 4 is in one of these cells, which removes 4 from the remaining of the cells. And then we know 8 has to be in one of these cells. But what can 8 be beside? 8 has to be beside a 7 or a 9. Well, oh, wait, no, some of these can be, in fact, a 9. Yeah, I realized that, yes, there can be 9s around here. A 9 can touch an 8, so if like this was a 9, then this would be an 8, but then that could be an 8. And then yeah, everything's fine there. Okay. What about these things? Do we figure out what they are? Did we figure out what they were? I mean, they're 21, but there's so many ways to make 21. Like, I'm pretty sure 6, 7, 8 makes 21, so you don't even need to have a 9 on a 3 cell line. Although that suddenly makes it a lot more interesting. Oh, wait, yeah, okay, no, I just realized that these are basically identical. Yeah, these are identical to these, I just rotated a little bit. So by equivalent logic, we know there's a 1-2 pair here and a 1-2 pair there. This and this see that, but that doesn't give us enough information. This sees all of those cells, this sees those cells. These cells are then seen. So 1-2 sees all of those cells, you'd have a 1-2 in the rest of the stuff then. Oh, okay, well, another thing here is there is now a 1-2 pair over here. So none of these can be 1 or 2. Okay, that is another restriction. Can we figure out what's on the opposite side of this? Yes, we can, because a 2 here could theoretically be beside a 1 or a 4, but because of the 1-2 pair here, this can't be a 1. So it would then have to be beside 4. 4. This 3 would have to be beside 6, and the 6 would have to be beside 3. And then we can do something similar here, where we'd have 3, 4, 6, and 8. 3, 4, 6, 8. Although that's not very helpful, I would say. Yeah. Yeah, it's not very helpful. Oh, these cells. These cells are also a 1-2 pair. I didn't see that, which means 2 can't be in any of these cells either. That does place a restriction. This can't be a 4 now, because a 4 would need to be next to an 8. It can't be next to a 2. So these can't be 4s. But more importantly, the only place 1 can be in this entire box has to be there. So that's a 1. That disambiguates a whole lot of stuff, because that's a 2, that's a 1, that's a 2, that's a 1. 2 in this box can really only be here. So that's a 2. That disambiguates a lot of stuff as well. And more importantly, this 2 cannot be beside a 1, so it has to be beside a 4. Okay. There's a lot more digits we have in the grid, so that's good. I think we can stop coloring some stuff now. Those colorings are getting a little bit distracting, so I will remove the coloring. I'll keep those lines. Those lines are fine. I'll probably recolor this one as well because I don't really like the grey. So pink it will be. Isn't this a 3, 4, 5, 6? Yes, this is a 3, 4, 5, 6, so that can't be a 5. That's something we should have seen a long time ago. But that can't be a 5. So 8 lies on one of these. What does 8 have to be beside? Could it be beside a 9? I mean, yeah, I'm pretty sure it can. Why not? Right, well, either way, maybe we could resolve more stuff. We're not doing anything similar to this, are we? No, I don't think so. Okay, I'm a little bit stuck here. I think maybe we look at this, maybe, because there's a 4 here. So what does this mean? We know this adds up to 21. Minus 4, that makes this a 7. 17, sorry. Did I say 7? 17. That makes this a 17. There's a lot of ways to make 17 though. I'm wondering, could this be a 9? If this was a 9, then this clearly can't be an 8 because 9, 8 is already 17 and whatever you add here makes it bigger than 17. So if this was a 9, this would then be a 3 or a 6. But because this was a 9, then this would have to be something to 8. This can't be a 6 because they'll put a 2 here in the same box. So this would be a 3, 5. So this would be 9, 3, 5. I think that's fine though. And then if we had an 8 here, then you'd have an 8 here puts a... Well then these would sum to 9, and then this can be an 8, so this is either 3 or 6, meaning this is either 3 or 6. This 3 puts a 6 here, that would be a 6, 3, 8. So 8, 3, 6. And then we have 9, 3, 5. What if this were a 7? Well then these would have to sum to 10. Ah, oh, wait, okay. This does look like it's adding to something. Because if this was a 7, this I have to add to 10. An 8 here puts a 2 here, which fails because there's a 2 in the box. A 6 here puts a 4 there, which fails immediately. So then this would have to be a 3. So for 7, 8, 9, this is always a 3. What about for 6? For 6, you need these to be an 11. Yes, an 8 can't be here because that puts a 3 here, which fails. So this can never be a 6 or an 8. In every case as it is, we've tried 6, 7, 8, 9. It can only be 6, 7, 8, 9 because it's consecutive to one of these cells. And for every case we check, this is always a 3. So that's always a 3. That's a 6. Wow, okay. So we remove 6 from these cells. This can't be a 3, that's a 4. This has to be a double of that, so it's an 8. Alright, I'll see you again. Okay, this is quite useful. So this sums to 14, right? Because this sums to 21. This is 7. 14. So this is either... Well, then this can't be a 7. Yeah, because the 7 puts another 7 there. So this can't be a 7. So this is, sums to 14, meaning this is either a 6, 8, or 5. If this was a 9, this would be a 5. What are we missing then? 7 is in one of these cells. So this cell must contain a 7 somehow. Therefore, well, it sums to 21. 21 minus 7 is 14. And 14 would be made of 5 and 9. It could also be made of 6 and 8. Right? If you had a 7 here and then a 6, 8 on the sides. Yes, it could. That is a possibility. Okay. Well, that's fine though. What about these? Well, then this can't be a 9. Because a 9 here puts an 8 here immediately. So that can't be a 9. 8 could be here though if a 6 was there. This has to be... Well, this could still be 6, 7, or 9, I think. Although I think there are a lot of restrictions regarding that. Yeah, because these have to sum to 21 minus 8, which is 13. So how do you make 13? Well, can this be a 9? If this was a 9, this would have to sum to 13 minus 9, that's 4. But a 4 is a 1-3 pair, which is not possible because of the 1 already in the box. If this was a 7, then this would have to sum to 13 minus 7, which is 6. But that also fails. 6 has 2 options. It's 1-5, which fails because of that, and 2-4, which fails because of that. So this can't be a 7 or a 9, so that is a 6, which must be beside 7. Then this is all resolved. This must therefore sum to 7, which, because it cannot be 2-5 or 1-6, must then be 3-4. That 3-4 is resolved by this 3 here, so that's a 4, that's a 3. Nice. Okay, so this can't be an 8. Oh, well, it must be adjacent to, it must be consecutive to 8, and can't be a 7, so it's just a 9. This then has to be a 5. This is therefore a 7 because it can be 5 or 9. This is therefore a 5 in the column. And these two cells are 6 and 8, which do indeed add to 14, so the total adds to 21. That works out so far. This 5 resolves this 3-5 pair. That's a 3 there and a 5 there. These are... Well, that 6 resolves this 6-8. These are 7 and 9, which is resolved by that 7, 9, 7. And we have the middle 3 columns. Alright, I'm pretty happy with this solve so far. What else do we have? Well, I mean, we have a lot more lines to check out. Although I am pretty concerned because the lines aren't actually bounded at all. Lines must, the shorter lines must contain higher digits, but very little of the higher digits actually see those lines. They don't see the lines fully, which is the problem, because this 9 sees these two cells, that's true, but then this could be a 9. And so we actually haven't removed the 9 from the box at all, from the line at all. Well, I'd say, okay, this looks somewhat useful, because one must be double the other, and the only way to do that is either 1-2, 2-4, 4-8, or 3-6. And it can't be a 1-2 or a 2-4 because of these cells. So this is either 3-6 or 4-8. I'm gonna mark those down first. 3-6 or 4-8. This 8 means that can't be an 8, so that can't be a 4. And this 6 means that can't be a 6, so this can't be a 3. Okay, now what do these two sum up to in each case? Well, they either sum to 3 plus 6, which is 9, or 4 plus 8, which is 12. Yes, okay. And then, yes, okay, I think we have it. Maybe. Because, okay, let's think about each case. This is either 3, 6, or 4, 8. Let's consider 4, 8 first. If this was 4, 8, then these have to sum to 21 minus 12, which is 9. And 9 can be made in a few different ways. It could be 1, 8, but that's not possible. It could be 2, 7, but that's not possible. It could be 3, 6, because we haven't used that yet. But it can't be 4, 5, because then there will be a 4 there, which makes a 4, 5 impossible. So if this was the case, then we'd have a 3, 6 pair there, which would then be resolved by this 6. So 3 here, 6 here is the first case. That is one case. Secondly, if this was a 3, 6, this would have to sum to 21 minus 9 is 12. 3, 6 here gives us a few options. It can't be 3, 9 because there's already a 3 there. It could be 4, 8, which would be resolved by this 4, 8 pair. So either a 4 here or an 8 there. Or it could be a 5, 7, no, 4, 8 is flipped. 8 here, 4 there. Or it could be a 5, 7, which is resolved by this 7 here. So this would then be a 5, this would then be a 7. No 7 here. So that is actually a few more options than I would have liked. Unfortunately, I don't think we can resolve any of that. Yeah, okay. Right, let's look at something else. Yeah, let us really look at something else. These 1, 2s force 1, 2s into one of these 4 cells. But the reason why that doesn't work, or it does work, but the only way you can put it, this can't be a 1 or a 2. Because this sums to 21. If you have a 1 here, these would then sum to 20, which can't be made as a sum of 2 digits. Like maximally you can have 8 and 9, which sum to 17, and that isn't as high as 20, so it doesn't work. But secondly, this can't be a 2 either, because then this would have to sum to 19, which again doesn't work. It has to sum to a maximum of 18. So this can't be a 1 or a 2, meaning that 1 and 2 have to lie on these cells. And we can do the same here. All of these are the only places 1 and 2 can exist. And I guess you could think of it as well, you can also think of it as, in this column, where can 1 and 2 go? 1 and 2 here means that these can be 1 and 2. These and these main 1 and 2 cannot be here, so you don't have 1 and 2 in the remaining cells. Yeah, that also works. Oh, in fact, yeah, it works even better because this isn't restricted similarly to this box. But by our previous logic, yeah, 1 and 2 has to be in one of these cells. Although 1 and 2 could be in that cell, couldn't it? Yeah, it could. So I guess... No, yeah, no. 1 and 2 has to be somewhere here, 1 and 2 has to be somewhere here. Yeah, okay, so this is right, I think. Yes, and then this forms a very particular... Yes, this forms a pair of sorts. Yes, this works. Okay. In this row, where can 1 and 2 go? Can 1 and 2 go there? That's the question I really want to know. Why couldn't it go there? It could, couldn't it? How would that work? How would that work? Could a 1 and 2 go there? Oh, I know 1 and 2 can't go there. Because a 1 here, you know, a 1 here would put a 2 here, which fails, this one. And a 2 here would put either a 1 here, which fails, or a 3 here, which fails. So this can't be a 1, 2 either. And therefore we are still in fact correct to say that these are 1, 2. This one, I don't know. This one, I don't know. Because I'm too tired to discuss whether that's a 1 or a 2, if that's possible or not. But for the rest of these boxes, yes, we can prove that in each box, these are the only 3 cells that can be 1 or 2. And that is somewhat useful, because what have we then proven in this column and this row? We've proven that in this column, 1 and 2 can't go in any of these cells. 1 and 2 have to be on the outside, and that forms a 1-2 pair in the column. And similarly in this row, 1 and 2 can't be in any of these cells, or these cells, forming a 1-2 pair here. That forms a 1-2 pair in this box, meaning that is not a 1 or a 2. Okay, I'm not entirely sure how that helps, but at least we found something. We found something. What a thing to say, haha. What about 3s? Well, this 3 sees those cells, this 3 sees those cells. Oh, yes, and this can be a 3. So 3 is just there in this box. Oh, 3 in the corner. We love 3s in the corner. Oh, and that forms a 1, 2, and 3. This is a 6, isn't it? What does that mean? Well, these cells sum to 21. And these are 6, so this sums to 15. Yes, and that works, because how can you make 15 in 2 cells? You can only make it with 6, 9, and 7, 8. But this can't be 6, 7, or 8 by these cells. So this is just a 9. And this has to be 15 minus that, so that's 6. Giving us a lot more digits. And now 6 can't be in here. So what does that mean about this set of 4? Well, we've already seen the options, and where can 6 be? 6 can be one of these cells. Okay, that doesn't give us as much as I thought it would be. I'd say then 6 is in one of these cells, but then we don't know which. I can mark those in though. What remaining cells are here? 4, 5, 7, 8. These can't be 5, and these can't be 4. I don't see anything else, but sure. Well, I think we can sort of say what has to be on here then. Because what have we not had yet? The remaining cells in this row is 1, 2, 4, 5, correct? Oh. Hi Lugia, welcome back, welcome back. I am still on this puzzle. It is kicking my ass a little, but I think we're doing fine. What are we missing? A 6. Yes, in this row, where can 6 be? It can't be in any of these cells. Can't be there, so 6 has to be here. So, okay, well we have a 6 here. We know this sums to 21. 21 minus 6 is 15. And 15 can only be made in 2 ways, 6, 9, and 7, 8. Haha, 6, 9, nice. Oh, it's okay. I can give you what I figured out so far. So every section of blue line, we figured out sums to 21. So these 5 cells sum to 21, these 4 cells sum to 21, and it goes on for every section of blue lines in each box. So that's what we figured out so far. And I'm figuring out how can you make 21 in here. And we know that in this row, 6 is in one of these 2 cells. So 6 is definitely part of this 21. And like, how else can you make 21 using only 6? The other digits you have to use are 7 and 8, I'm pretty sure. Because you need a 6 and then another 15, right? But then 15 in 2 cells is either a 6-9, nice, or a 7-8. And you can't have 6-9 because you already have a 6 somewhere. So it would then have to be 6, 7, and 8. Which works. Because these do sum to 21. And then the remaining cells are 1, 2, 1, 2, 4, 5, 9? Yes, 1, 2, 4, 5, 9. And these can't be 9. So 9 in this box is only in there. These can't be 1 or 2 because of these cells. So that's a 4 or 5. Okay, this works so far. And this 9 actually does help you in this cell as well, because this must sum to 21, correct? And what is the maximum you can put in these 3 cells? Because they cannot repeat it, they have to be 6, 7, 8 at maximum. And 6, 7, 8 just happens to add to 21. So you must put as big as possible in these cells. So these are 6, 7, and 8. And then this 6 and this 8 removes that, so that's a 7. So these are not 7. Then these are 3, 4, 5, 9. Which is cool because I think this sums to 21. 3 plus 4 plus 5 is 12, plus 9 is 21. Yes. So this is also correct. So this is not a 9. This is not a 9. Oh, now these are 4. This is not a 5. Or a 3. Wow, okay, I didn't really see that. All of these help here, so that's a 4. This is not a 3. So this can't be a 9 because I forgot to tell you, the white dot means that these 2 cells are consecutive. So like one of them is 1 bigger than the other. The difference is 1 basically. So this definitely can't be a 9. And then the black dots means that one is double the other. So you see we have 2, 4, and then 3, 6, and then 4, 8, which all makes sense. So that works. And then in this box, where does 3 go? These 3s see these cells. This 3 sees that. And we know there's a 3 in one of these cells, which will then see that. So 3 can only be there. Oh, confetti. Okay, and then these cells are 1, 2, 4, 5. That helps, right? Because all of these cells are set basically. So these cells remaining are 1, 2, 4, and 5. And this helps because this can't be 1, 2, or 4. So it's a 5. So now these can be 5. Yeah. Bro really just rigrolled me in chat. Thank you for that, by the way. What are these cells? I don't know, a 9 must exist in these cells though. Not very helpful. But we're working our way through it. Oh, well, this can be a 7. So... oh my goodness. What does a small number in the top left of some cells mean? Oh, these? Things like these means that in these 3 cells there must be a 1 somewhere and there must be a 2 somewhere. It's a very loose way to write it, but because of the interface right now, this is the only thing I can do. It's very hard to say otherwise anyway. And then this one, don't bother. This one is just a whole new different set. So we have figured out the options for this, and it's like either the top corner cells are correct or the middle cells are correct. One of those. And then this 7 means that if the middle was correct, this couldn't be a 7. And then in that case, because this has to sum to 21, 4, 3, 6 sum to 13, so this will have to sum to 8. So in these 4 cells, you either have 3, 4, 8, 6, or you would have 4, 3, 6, 8, like that. And that's actually just, I can just write that down now. So this is 3 or 4, this is 4 or 3, this is 8 or 6, and then this is 6 or 8. So there you go. That was so scuffed. But the remaining cells here are 5, 7, and 9, which are missing from the box. And then this sums to 21, right? 5 plus 7 is 12, yep, plus 9 is 21. Okay, 5 and 9 there make this a 7. And then there can't be 7 in there. What else do we have? We have the 6, 8 pair here, removes 8 from these cells. So now 7 can't be in here as well, because, you know, if you had a 7 beside, if you had a 7 here, the other cell would have to be like 8. It can't be a 6, so it'd have to be an 8. So it can't be 7 either, so that gives us our digits, 4 and 5. So this can't be a 4, this can't be a 5, these are 7 and 8. This 4 means that can't be a 4, so that's a 3, that's a 4. This is now double of 3, so it's a 6, it can't be an 8. Which then resolves this. This has to be 8, 6. And then 3 here removes a 3 from that. Here is 5 and 9, so this can't be a 5 anymore, it's a 3. And that is pretty decent progress, I think. What are these cells? Yeah, okay. This is a 1-2 pair, so these kind of 1 or 2 in them. The remaining cells are 7 and 9, which sum to 16. So these sum to 21. Minus 16 gives us 5, that's a 5. So 6 can only be here then, because of this 6, I guess. And then the remaining cells here are 1, 2, 4, 8. 1, 2, 4, 8. Oh, and this can't be 1, 2, or 4, so that is an 8. And 1, 2, 4, 6, 8. Oh my god, I have to do so much math. 1, 2, 4, 6, 8. 1 plus 2 is 3, plus 4 is 7, plus 6 is 13, plus 8 is 21. Okay. Math is correct. This is fine still. Good. What are we missing now? Here maybe? I think this is where everything gets resolved, this consecutive section. We haven't touched it yet. Okay, what about here? What is missing from here? 1, 2, 4, 8 again. So 1, 2, 4, 8. This can't be 1 or 2. This can't be 4. And this has to sum to 21 somehow. So 3 and 5 adds to 8. So this must sum to 13. Okay, how do you make 13 out of these 3 cells? If you did have an 8, then there would be 1, 2, 4, which is 7, which is too low. So we must have an 8 somewhere. Oh, in fact, we already know there's an 8 here. And then 13 minus 8 is 5. So the remaining cells have to sum to 5. So you can't have a 2, because a 2 would need a 3. Yeah, a 2 would then need a 3. So you can't have a 2 in here, which means we can remove the 2's here. That works. Because now 2 must be in one of these cells in this row. And the 2 here would remove a 2 from that. Yeah. Okay, and then here we have a 1, 4 pair. So that's fixed somewhat. And the remaining cells would be 2, 7, 9. But 2 can't be here. So that's where 2 goes. So this isn't 2. Oh, nice music, by the way. This 7 is next to a 6 or an 8. And then a 9 is just next to an 8. And then this 8 here sees that, so this can only be a 6, which is beside 7. Then this is resolved, that's a 9 and that's a 7. This cell must be the final one, which is a 9. A 9. That fixes this, right? This has to be a 5. This has to be a 9. This is fixed, this has to be a 9, this has to be a 5. This can't be a 5. So where does 5 go in this box? It can only go here. This can't be a 6 or a 7, so that is an 8. This is therefore a 7, then that is a 6. This is resolved by that, so that is an 8, that is a 7. This puzzle is now going to be solved. This can't be an 8, so that is a 4. This is a 1. This is an 8. This 1 means that's a 4. So this doesn't have that. And then this 1 means that is a 2. This is a 1. This is a 2. This 1, this 2 means that is a 4, that is a 1, and this 1 means that is a 2, that is a 1. Oh, there we go. Solved. Yay. That was satisfying. Oh, I like that.